Okay, this is example 3. This is where we want to continue the example. Okay, for three-phase diagram, the best way for you to attempt question is when you have your three-phase diagram and then you have already prepared all the equations so that you can refer very quickly when you attempt to your question. So okay, this is me preparing my short notes on all the equation that already discussed during the class. So I'm ready to attempt the question for example 3. Okay, the strategy is to read the question carefully, gather the important data, and then we try to answer this question. So for example 3, this is the solution. Okay, again you need to read carefully. In the sample of moist clay soil, the void ratio is 0.788 and the degree of saturation is 0.93. Assuming GS 2.7, determine the dry density. So this is the question. And then the bulk density and the water content. So it's quite straightforward, but let's gather the information first. Okay, given the void ratio E is equal to 0.788, and then it's giving the value for degree of saturation is equal to 0.93. So SR is equal to 0.493. Now we read the question. The question asks for dry density. So right now, okay, with limited data, we cannot answer for this one. Of course, you need to bring your equation first. So this is my short notes on dry density. So dry density is equal to mass of solid divided by total volume, or given by ms over v. And it also suggested that dry density of soil is given by Gs rho W over 1 plus E. Okay, this equation, when we replace all the equation from your three-phase diagram into this equation, and then we get this equation. So I'm using that one. So rho D is Gs rho W 1 plus E. So by now, we already know that rho W is equal to 1000 kg per meter cubic, or we can also use density water is 1 megagram per meter cubic. So I have the value for Gs. Okay, I also have raw water value, and then from the data also have E value. So just substitute the value. Gs is given here. Say this is Gs value, 2.7. So Gs 2.7 multiplied by 1, because I'm using megagram per meter cubic, divide by 1 plus this is E, 0.788. So use your calculator, and then we get the value of megagram per meter cubic. Okay, that one is to answer question. The first one, dry density. Now, next, they ask about bulk density, and of course, for bulk density, okay, we need to refer for the bulk density equation. So bulk density is given by total mass divided by total volume. So this will be M over V. Total mass, we know that it is mass of water plus mass of solid divided by total volume. So we use three-phase diagram, substitute mass of water by WGS rho W. Okay, that one is from your three-phase diagram. So this is your three-phase diagram. This is mass of water. WGS rho W. And then mass of solid is GS rho W. So that substitute that one, divide by 1 plus E. So this is the equation that I can use if I want. Okay, but right now we don't have the value for water content. So what I can do is to use this equation. Okay, rather than use this equation, okay, when I calculate for bulk density, I also can use GS rho W plus SRE rho W 1 plus E. Because in the question I have SR value, I have E value, and also have GS value. So using that equation, GS rho W plus SRE rho W divided by 1 plus E. So now substitute with value. GS is 2.7, rho W is 1, SR is 0.93, E is 0.788, rho W is 1, and then 1 plus 0.788. So use calculator, and then use calculator, and then you can get your answer with 192 megagram per meter cubic. So next, it asks you about what is the value for water content. So water content is given by SRE divided by GS. So this one, you need to refer to your moisture content equation here. This is what I get from the slide. W is equal to SRE over GS. So I'm using that one, and then substitute the value. Okay, I get the answer of 0.2771, or you can put it into percentage as 27.1.